So today we are solving an exponential equation, and maybe the best approach here is to divide each term by the lowest base here, which is 9 to the power of x. So let's divide each term by 9 to the power of x. So we have 9 to the power of x over 9 to the power of x itself, 12 to the power of x over the same. So dividing each term by 9 to the power of x. What happens here? Anything divided by itself, you end up with 1. And then because the exponents are the same, we can rewrite this term like that. And again, for the very same reason, we can rewrite. Notice the exponents are the same. So we can afford to do that. Now, 12 over 9 can be simplified. We can divide numerator and denominator by 3, so we end up with 4/3. And of course, 16 over 9, well, 16 over 9 is 4/3 all square. And of course, we have to put back the exponent there, x. Now, so we end up with 1 plus 4/3 x. Now, I'm going to do something. I'm going to switch the x and the 2. And this comes from a law in indices that says x to the power of 8b is x. And of course, we can rearrange. Notice both of these is x to the ab. But you multiply a times b, the order is not important. So in the same way, this is 4/3 to the power of 2x, but we can rewrite. Conveniently, we put the x, because we want a term to look like what we have over here. And then we can put the 2. So we can switch it to on the x. That's very convenient for what we plan to do next, which is substitution. So we can let 4/3 to the power of x be equal to y, and of course we can use substitution. So we have 1 plus y, so replace this with y, and again 4/3 to the power of x, replace with y, so we end up with y squared, and we end up with a quadratic. So let's put everything on one side and the right hand side. So we have 0 y squared minus y minus 1. So we have a quadratic equation there. And the formula, let me just put the quadratic formula there. Since the expression cannot be factorized, so we turn to the formula. So a is the coefficient of the square term here, b coefficient of the y, which is minus 1, and c is a constant, negative 1. So minus b, that's minus 1, which is positive 1, plus or minus the square root of b squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 1. So the double of negative gives us a positive 4, all upon 2a. Now a is 1, so 2 times 1, that's 2. Now, the value of y is definitely a positive value. And let me explain why. 1 plus 4, that's root 5. So it's 1 plus root 5 all upon 2. Now, 4/3 to the power of x is equal to y. Now, whatever the value of x is, if x is 0, then y is 1. If x is a negative number, then y will still be a positive number. And if x is positive, then the y value is still a positive number. So the value of y has to be a positive value. So we use a 1 plus root 5 over 2. 1 minus root 5 over 2 will not be a possible solution for y. Now, of course, let me just restate it. Recall that 4/3 to the power of x is equal to y. So remember, we're solving for x now. So 4/3 to the power of x is equal to what's y? 1 plus root 5 upon 2. So we can take the log of both sides. So we can log 4/3 exponent x, and we can log, natural log, that is the right hand side. And now, law of logarithms, we can bring the exponent to the front there. So we have x ln 4/3 equal ln 1 plus root 5 over 2. And of course, we're solving for x, so we divide both sides by ln 4/3. So ln 4/3 into itself, we get 1. So x is ln 1 plus root 5 over 2. Divide by ln 4/3, and that's our solution. Let me just work it. It's all of ln 1 plus root 5 all upon 2 upon ln 4/3.